Describing key features of graphs. The learning targets for today: determine local max and mins on a graph, determine intervals of increasing and decreasing, and talking about x and y intercepts of a graph. The x-intercepts is the point where the graph crosses the x-axis. If we look at our example graph, there are 3 points, -3, 0, 1, 0, and 5, 0. Those are all x-intercepts. The y-intercept is the point where the graph crosses the y-axis. We have one y-intercept, 0, 2. Remember, we should only have one y-intercept if this is a function. Okay. A function is increasing on an interval if the y value increases as the x value increases. What that means is, as we're looking at a graph, from left to right, we should be increasing on the y-axis from left to right. There's my first increasing interval from left to right. Here's my second increasing interval. On your sheet, if you would like to write down increasing on those intervals, you can. Okay, got some increasing intervals there. A function is decreasing on an interval if the y value decreases as the x value increases, or from left to right, the y value is decreasing. I've got one decreasing interval on this graph, and if you want to write decreasing there, you certainly can. If it helps you to use these different colors as we go along, that's fine. Okay, the next key feature. Okay, on your sheet it said the relative minimums and maximums. So the maximum is the y value of the highest point in a particular region of a graph. A relative maximum, or another word you would hear is local maximum. Okay. So my relative maximum here, so the highest point that we can actually see, would be -1, 4. Remember, these graphs do continue. That's why they have arrows. Okay. But relatively speaking, okay, in this particular region, my maximum would be -1, 4. And the local or relative minimum is the y value of the lowest point in a particular region of a graph. So locally, we've got a minimum of 3, -4. Those are relative or local. So in a particular region of a graph, that's the lowest point. Again, the entire graph, or globally, this graph would be continuing forever in both directions, but those are relative or local maximums and minimums. This last piece, okay, zeros, roots, solutions, and x-intercepts are all names that describe the x values of a graph whose corresponding y value is 0. In other words, zeros, roots, and solutions are other words we will hear for x-intercepts. Just know that those words are used interchangeably throughout math. Given certain situations, we use our particular word for that vocab. Just know that all of these terms will be used interchangeably. My key features on this graph, the first of which would be our x-intercepts. I have an x-intercept at -4, 0, another at -3, 0, a third one at +1/2, 0, and a fourth at 3, 0. My y-intercept, where it crosses the y-axis, would be 0 and -2. Okay, I've got a couple different intervals here. I've got 2 increasing and 2 decreasing intervals. My first increasing interval would be from -infinity on the x-axis to this point here, which would be roughly -3.5. We don't include -infinity, but we do include -3.5, so that's the notation we're going to use there. I have a second increasing interval from this point to that point here. Okay, so that's my second increasing interval. That would be from, on the x-axis, -1 to +2. Those are included. My decreasing intervals, change colors here, would be from this point to this point. Again, it's decreasing because it is going down from left to right. That would be from -3.5 on the x to, roughly -1.5. Okay, both of which are included on the graph. And the last one would be from this high point here all the way down. So that would be from a +2 to +infinity. Again, we include 2. Can't include infinity. That's not a possible number to include. That's the notation that we use to write that out. Okay. Local maximum, okay, the highest of which lies on this line, which crosses the y at a +5. The local minimum, okay, lies at this line here, which is y equals -5.5. It's our local minimum. The domain, all possible inputs or x values. Okay, remember these graphs continue to the left and to the right, so my domain would be all real numbers. Or we have a second notation here. It's a capital R with just another line here. Okay, it's another notation. My range, up and down, okay, I am bound by a maximum, a global maximum of 5, but I continue forever in the negative direction, so my y has to be less than or equal to a +5. And here's our last example here. Okay, our x-intercepts are -1, 0, and 3, 0. I have a single y-intercept at 0, -3. Okay, I am increasing from this value onward. So on the x-axis, that would be from 1 to infinity. My decreasing interval is everything on the left down to that point. So I'd be -infinity to a +1 on the x-axis. I do not have a relative maximum, so no relative max. My relative minimum would be y equals -4. My domain here, again, my domain is my x values. It continues in both directions, so I have all real numbers. And my range is my possible outputs, or my y's. I am bound by this line here. That's everything greater than that. So y would be greater than or equal to that -4 minimum.